Okay, this is a quick solutions video for those of you who sat your test last Thursday on trigonometry. I'm going to be rattling through the problems. I've got about 25 minutes, so we'll try to do most of them in as much depth as we can. I did take the last question off the test, so it ended up only being 5 questions, but we'll see how we go. So the first question says sine of alpha equals 5 over 13, where alpha is between 0 and 2 pi over 2. Well, that's important because that means we've only got a right-angled triangle. There's no obtuse angles in there. So there's nothing above pi over 2. And so we've got a triangle like this, and we know that if we've got some value of alpha there, that equals 5 over 13. Well, let's think about our rule. Well, we've got sine. Sine is opposite over adjacent, opposite over hypotenuse. And so in our case here, the values that we've got are 5 and 13 for those two. And so therefore, if we're working with a right-angled triangle, we can find our last value here, and therefore we can use what, therefore we can figure out what cos of alpha would be. Because cos of alpha is going to be adjacent, whatever this value here is, adjacent over the hypotenuse. So we know that it's going to include this value, the hypotenuse, but we also need the adjacent value. So that one used this one and this one. This one's going to be using hypotenuse and adjacent. And so to find our adjacent value, we can simply use Pythagoras. So 13 squared equals, or 13 squared minus 5 squared equals our adjacent squared. Well, 13 squared is 169 minus 25 is the adjacent squared. So therefore the adjacent is just the square root of 144, which is 12. So we get our value there as 12, and therefore we can use that to find what cos of alpha is, because we know that cos of alpha is a over h, or adjacent over hypotenuse. And so in our case there, our adjacent is 12 and our hypotenuse is 13. Cos of 2 alpha, we know a special rule for this, and that's our double angle formula, and that's the fact that we could do this with triangles, but we're not going to do that. We're going to do it using our double angle formula, and so therefore we've got cos of 2 alpha, by definition from your formula booklet, will be equal to cos squared of alpha minus sine squared of alpha, not to be confused with cos squared plus sine squared equals 1. Well, we know that cos of alpha is 12 over 13, and we know that sine of alpha is 5 over 13. What I might do actually is I might do 1 minus 2 sine squared alpha, also given to you. All I've done is I've switched this for 1 minus sine squared. And I've used that rule, and therefore I get 1 minus 2 sine squared. And so in this case here, double underline my answers. Wasn't very neat. We would get 1 minus 2 lots of 5 over 13 squared. Well, that's 1 minus 50 over 169, which is 119 over 169. And that there is our answer. And all we've used there is our double angle formula. Okay, find all the solutions in the interval 0 to 2 pi of that equation there. Well, whenever you're faced with a problem like this, you want to make either everything into cos of x's or everything into sine of x's. It's much more difficult in this case to convert sine of x into cos of x because we don't know a formula for it. But we do know a formula in which we can change our cos of x squared into sine of x squared. And that's our classic, if we've got 1 minus sine squared of x plus 1 equals 5 sine of x. And then we want to aim to create it into a quadratic. We've got a squared term, we've got a non-squared term, and so therefore we can create a quadratic out of this. And so let's do that quickly. So we get 2 minus 2 sine squared of x plus 1 equals 5 sine of x. Taking everything to the right hand side, I get 0 equals 2 sine squared of x plus 5 of sine of x minus 1. And so now solving that for solutions, we need to factorize it to start off with. Let's double check I've done that right. Plus, and it'd be minus 3. And so therefore, factorize, we have to have 2 sine of x. One bracket, and then the other bracket needs to be a sine of x. And then to get to 3, we need 1 and 3. And so thinking of a combination, plus 3 minus 1 should get us there, because we're going to get minus 3. And then we're also going to get our plus 5 sine of x, because we're going to get 6 sine of x minus 1 sine of x. I'm actually going to complete the rest of this question on a separate sheet of paper. Let me add one here. And so if we take this problem and we pull it down, this is question 2. We can then solve these individually, equal to 0. So we've got 2 sine of x minus 1 equal to 0, or we've got 0 equals sine of x plus 3. Well, that leads to sine of x equals minus 3. Think about your sine graph. Your sine graph never equals minus 3. It alternates between positive 1 and negative 1, and so therefore that's impossible. And then we'll look at the other solution. That gives us that sine of x equals a half. So we know that we're going to get some point here that's going to cross wherever sine of x equals a half. And that implies that you can plug it into a calculator, but that x would be the x would be 30, I think. The way that I'm doing this, 30 degrees, which is actually pi over 6, but the way that I've done that is that I've used my key triangle, which is this one here, with sides 2, 1, and square root 3. And then if there's my 30 degrees, then it'd be 1 over 2. And so pi over 6. So we know that the first solution here is at pi over 6. To find the second one here, the easiest way is to think about my diagram. We know that it crosses through here at pi, here at 2 pi, there at 0, and we know that it's pretty much symmetrical, and so this point here would actually just be pi minus pi over 6. The other way to think about this would be with the unit circle. So if you draw a quick sketch of your unit circle, and then if you looked at where pi over 6 was on your unit circle, pi over 6 is about here. Well, sine of x for solutions is just reflected in the y-axis, and so therefore we'd also need to find this one here, and that there's pi minus pi over 6. Whatever you find easiest for finding multiple solutions. And so in this case here, we get our second solution as pi over 6, and then pi minus pi over 6 can be 5 pi over 6. Okay, question 2 done. Question 3, given that 5 sine of x equals 2 cos of x, find the value of tan of x. It's only worth 1 mark. 5 sine of x equals 2 cos of x. 5 sine of x equals 2 cos of x. Find the value of tan of, I think it was theta actually in the question. Find the value of tan theta. Well, we know that tan theta is sine theta over cos theta. That's in your formula booklet. And so therefore all I need to do is divide this here by cos theta. If I do that, I need to divide this here also by cos theta, which is handy because it cancels. And so we get 5 tan theta equals 2, and so therefore tan theta equals 2 over 5. Part B here. If there's a part B, usually we're going to use our value for part A. So solve for 0 to 360 degrees. Key part here is this one here is now in degrees, whereas the last question was in radians. So your answers have to be in degrees. And all they've changed here is theta for 2x. So all they've done is they've changed theta for 2x, and so therefore we know that what we've learnt above still applies. So tan 2 of x equals 2 over 5. And for solutions, x to 360. Okay, and so tan of x, either you can think of it as on a graph. I think tan of x is so simple actually, especially when you think of it as a graph, because all of the lines are exactly a distance of pi from one another. That's always pi. So it's just adding or subtracting pi. And so really we got 0 here, that there's pi, because it's whatever 0 is plus pi, 2 pi, 3 pi. Or, because our question is in degrees, we can do that all with degrees. And so in our case, pi is 180 degrees, 180 degrees, 180 degrees, and so therefore this is 180 degrees, 360, 440 degrees. And so if we add those all together, we get, just recording the solutions in here, 540 degrees, and then the next one up would be 720 degrees. And so we can use this here to find what our value for x is. The reason why I've put down x between 0 and 360, and I've written down it up to 720 degrees, is because the issue that we're going to encounter is that we're going to get 2x lots of tan inverse of 2 over 5. And the issue is that tan inverse of 2 over 5 is basically saying that what is the value for theta when x is 2 over 5? That's what it's going to give you, but in fact this is equal to 2x. And that's important because we're going to get a value for theta that's equal to 2x, so we need to divide by 2 at the end. And so really all of this is basically squished into the 360 because everything is halved. All of your degrees are halved. I'll show you that in practice as we do more of these problems. So if I plug in, I'm not going to do that in my head, tan of 2 over 5, 2 divided by 5, I get 21.8 degrees to 1 decimal place don't, which is what they wanted in the question. Now I need to find the other ones. Well, the other ones are just all adding pi. So really the other solutions are just going to be 21.8 plus 180, 21.8 plus 360 degrees, 21.8 plus 540 degrees. And you could do the 1 past 720, but if you notice everything in here, because it's going to be halved within our region of 360, we don't need anything past there. and the line that's above 0 is actually over 720, and so therefore we don't need to worry about it. So finding the solutions, then we've got 2x equals 21.8, and then also 201.8, and 381.8, and then our final one will be 561.8. And those are all degrees. And so this is what I meant now. All my solutions are going to be divided by 2. And so x, because x is within the region of 0 to 360, either you can, there's the other way of thinking about it is x is between 0 and 360, so therefore 2x would be between 0 and 720. And that's the other way I see people do these. Either you can think of it as dividing by 2 at the end, or you can think of it, 2x is between 0 and 720, and so you've got to draw your graph up until 720. And it's the same as if you had x over 2, you'd have to halve it. 2x, you've got to double it. And so therefore, my value for x would be all of these divided by 2. So I'd get 10.9, 100.9, 190.9. I should be doing this in my head, really. I'm getting lazy. And then 280. 280.9. And so those are all of our solutions between 0 and 360. There are 4 of them. That was quite a hefty question. Okay, question 4. Using the identity cos of a plus b equals cos of a, cos of b, and sine of a and minus sine of a, sine of b. Well, in our case here, we've got cos of 2a. Well, cos of 2a is just cos of a plus a. And so if we apply the above identity, and instead we think of all of these as a's, what have we really got? We've just got cos of a squared, or cos squared of a, minus sine squared of a. And our final step is just to use the fact that cos squared of alpha, or cos squared of a, is 1 minus sine squared of a, minus sine squared of a. I've just used the fact that that 1 equals cos squared plus sine squared, and then rearrange that, so 1 minus sine squared equals cos squared. And so applying that, we get 1 minus 2 sine squared of a, and as it's a proof question, you work from left to right, therefore left-hand side equals right-hand side. It's just a nice step you can put at the end to just show that you've completed the problem. Prove that cos of 1 minus cos 2 theta over sine 2 theta equals tan theta. Well, 1 minus cos 2 theta over sine 2 theta. Again, I'm going to work from the left-hand side because there's more on the left-hand side to get to the right-hand side. And I'm going to use what I've learnt in the part above. So 1 minus 2 sine theta, if I just replace my a's by theta, over sine 2 theta. Well, sine 2 theta is 2 sine theta, cos theta from your formula booklets. And so therefore I get 2 sine theta on the top, sine squared theta on the top, over 2 sine theta, cos theta on the bottom. And then by cancelling out those there, I'm left with, and also I can cancel out my 2's, I'm left with sine theta over cos of theta, which is just tan theta. and you've shown the question as given. I've got 8 minutes or so left. I'll try to do this last question in 8 minutes, and we'll see how far we get. But this is also a great question worth going through if you find the time. So show that cos 2x over cos of x plus sine of x equals cos of x minus sine of x. Well, cos 2x would be cos squared of x minus sine squared of x, again working from the left-hand side because there's more on the left-hand side, over cos of x plus sine of x. If we then spot here, if we've got like an x squared plus y squared, if you imagine, minus y squared, you can actually factorize this into x minus y, x plus y. You can double check that works, but we can do the same here. So we get cos of x minus sine of x, cos of x plus sine of x, all over cos of x plus sine of x. And so what we notice here is that those would cancel, and we're just left with what we've got on the left-hand side, on the right-hand side. The next question, part II, wants to show that that's the case. Okay. That's a little bit more tricky. We're going to use the double angle formulas on the left-hand side, I think, to get across the right-hand side. So if we do a half, cos squared x minus sine squared x, and we just start going for it, and then we'd have minus a half. Actually, I'm going to take my half outside of the whole lot for now. Minus 2 sine of x cos of x. And now I'm going to multiply through with my half on the inside. In fact, what I'm going to do first is I'm going to switch this into 1 over 2 cos squared of x minus 1, the first bracket. And I can do that again by my sine squared plus cos squared equals 1, and then minus 2 sine of x cos of x. And when I take my half inside here, I would just be left with cos squared of x minus a half minus sine of x cos of x, which is what they got on the right-hand side if we rearrange. Hence, in part B, hence or otherwise, show that the equation equals a half. Okay, well, we're going to use everything we just learnt, so can be written as that, okay? So using what we've just found out, so this bit here is obviously part A of our question. And then let's see where we go from there. So therefore we got cos of theta times part A of our question, which is cos of theta minus sine of theta equals half. And then if we multiply that out, we would get cos squared theta minus cos theta sine theta equals a half. Does that remind us of anything? Should do, because what we're going to get is we're going to get cos squared theta minus cos theta sine theta minus a half equals 0. Well, that there's actually just part B. If you look above, it's exactly the same as part B. And so therefore we know that that implies that a half cos 2 theta minus sine 2 theta by part B is equal to 0. And so if you multiply through by 2, because you've got 0 on the other side, it doesn't affect anything, I can cross that out. And so all I should be left with is cos 2 theta equals sine 2 theta, taking sine 2 theta to the other side, which is what they wanted in the question. And hence, solve for theta between 0 and 2 pi. So I've got sine of 2 theta equals cos of 2 theta. First step would be to divide by cos 2 theta. If I divide through by cos 2 theta, I'm going to find that these two here cancel. Well, they don't quite cancel, I'm left with 1. And then the others are going to give me tan 2 theta equals 1. Great. Final step then is to find the solutions between 0 and 2 pi. So again, theta's solutions are between 0 and 2 pi. 2 theta's solutions are going to be between 0 and 4 pi. So if you wanted to do a quick sketch of your diagram, we need between 0 and 4 pi. So we know that, again, it goes up 180, 360, 540, 720, or in other words, pi, 2 pi, 3 pi, 4 pi. Pi, 2 pi, 3 pi, and 4 pi. And so then if you think about where 1 would be, 1's going to be about here, because 10 doesn't have a maximum or minimum. It's a bit like your graph y equals x cubed. And so again, we're going to get 4 solutions. And so let's figure out what our first solution is. Well, one way of doing it is with our triangle, or you can just plug it into your calculator. And therefore, if you use that triangle, square root 2, this angle here is 45 degrees, which is pi over 4. So I know that my first solution for 2 theta is pi over 4. So my next solution is pi over 4 plus pi, which is 5 pi over 4. My next solution after that would be 5 pi over 4 plus pi, which is 9 pi over 4. The one after that would be 9 pi over 4 plus pi, it's 13 pi over 4. And then if you divide this all by 2, we would get pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. And so that's all your solutions there for tan 2 theta equal to 1 between 0 and 2 pi. Well, I hope that was helpful, and I'll also be posting the PDF up for your convenience.